Alrighty. Alright, part 3, here we go. Which of the following has the most moles and non-metallic atoms? Alright, now you gotta pay attention to this one, because this one is a real tricky question. So we got non-metallic atoms. Alright, so this is the way it's gonna work. We can eliminate which one of these answer choices automatically. Why can we eliminate C? It's a metal. Okay, there is no non-metal inside of this thing. Okay, so that's first off. Second off, here's what we're going to do. We're going to set up, we have 100 grams, and 100 grams. So which one of these guys is going to be the same, the top or the bottom? All right, let's pull out this guy again. Hey, move away. No, I just want, crap. Hang on. There we go, paste. All right, so let's look at that. All right, so we are in grams right here. We need to go to moles. So which box is going to be the same, top or bottom? Top, right? So 1 mole, and 1 mole. So this is NaCl. This is, let's see what we say this one was. Cl2 and S. So this one over here is Cl2, and this one over here is S. All right, so that's 58.44. All right, and then this one right here is going to be 70.9, if I remember correctly. And this guy right here is 32.07. All right, so the way this goes, and before you even put stuff into a calculator, what you need to look at is what are you dividing by. So you need to look at what you're dividing by. All right, so it's 100 divided by 58, 100 divided by 70, 100 divided by 32. Which one of these guys is going to give you the biggest number? 32, why? It's dividing by the smallest number, right? So this one over here is going to give you the smallest one. Which one's going to give you the largest one? Which one's going to give you the smallest one? 70. All right. So do this in your calculator. What's 100 divided by 58? It should be 1.71. That's what I got. 58.44. Yeah, 1.71. All right. What's 100 divided by 70.9? 1.41. And then 100 divided by 32.07? 3.12. All right. So now here we go. Can we answer the question right now? No. Why? Have I isolated the Cl, the moles of the non-metal? No. Have I isolated this one? No. All right, so right here, NaCl, how many atoms of Cl are trapped up in this problem? 1. Oh, wait. Well, then I did. So this is 1.71 mole of Cl. What about this one? What do I have to do special to this one? Multiply by 2. Because think about it, all right? Let's say that you're making, what's another good example? A peanut butter slice and a jelly slice. Okay? Oh, no, that's not good. Eggo. Eggo peanut butter. Put one side of the peanut butter on an Eggo, other side of the peanut butter on an Eggo, smack them together. Okay? You guys need to do that. Nutella is nasty. Hang on, I have to have a philosophical discussion with my all right, so back on track. If I had, I don't know, let's see, what would be another example, guys? Bagels. There you go. Okay, so I got 2 slices of a bagel. All right. One side has cream cheese, the other side has cream cheese. I have to smack them together in order to form one bagel. All right. It happens. All right. So I need 2 slices, but how many slices total do I have? 2. You have 2, right? So same thing here. I need to multiply 1.41 times 2. That gives me 2.82. Okay, so which one is the biggest? Which one has the most non-metallic atoms? S. All right, so Originally, it is what we thought it was. All right, so let's look at percent composition. All right, percent composition. Now, this is where a lot of y'all have issues, and mainly the only reason why you have issues is because you get the wrong formula. All right, so let's look at percent composition by mass of nitrogen and nitrogen monoxide. So in this case right here, what it's going to end up being, what is my formula for nitrogen monoxide? No. All right, we got no. No? Okay. So we got 14.01 plus 16. So on the bottom is the total molar mass. On top is the molar mass of the element times the abundance of that element. In this case, what is it that we're looking for in this percent by mass problem? Nitrogen. So what mass is going to go on top? 14.01 times what? Times abundance, which is 1. And then at the end, we multiply by 100%. So this ends up being 46.7%. Now, if you get a number over 100, the thing that I would suggest you do is go back to your molar mass and put parentheses around it. Or, better yet, find the molar mass of the compound first and then divide by that. So in this case, I would have gone off to the side and done 30.01, and then in my calculator, go back and do 14.01 divided by 30.01. That can be really challenging, especially on some of these guys over here like calcium sulfate. When you get multiple elements in there, it's really, really difficult, and you're more prone to make a mistake somewhere. Yes, Bree? Never mind then. All right, what is percent by mass of sulfur in calcium sulfate? What's the formula for calcium sulfate? We did this earlier, right? Well, we did something simpler. Yeah, we did. Yeah, it's CaSO4. We did that on the first page, CaSO4. All right, so in this case, what we got going on here is we're going to do 40.08 plus what, guys? 0.07 plus 4 times 16. All right, so up on top, we're going to do 32.07. Multiply the whole thing by 100%, and you end up getting your answer. Now, for grins and giggles, if we did for oxygen, it would be 4 times 16 over 40.08 plus 32.07 plus 4 times 16. All right, that's to show you the mass times abundance part. All right, so that part right there is why it's important, and you multiply the whole thing by 100%. All right, any questions? Moving on. All right. No, that's this stuff. All right, so just had a question. Empirical formulas is what we're doing next. That's where you hold divide by the lowest number, blah, 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 blah. And this part right here, what we're looking at, is all we're asked to find is how much of this sample is nitrogen. Okay? So if we were, again, let's go back to a chocolate chip analogy. Okay? Or no, let's stick with ham sandwich. All right? Let's say the bread weighs 2 ounces. The cheese weighs, I don't know, let's say 6 ounces, some pretty fat cheese. And then the ham / turkey, for those conscious about that stuff, is 1 ounce. Okay? Because cheese is awesome. Okay? Anyway, so to figure out the total amount, I add all these up. So that's 2 plus 6 plus 7, that's 8, that's 9 ounces total, right? Then if I was to divide, let's say how much this percent of cheese is inside of there. I would do 6 divided by 9, right? Because what I divide by the amount the cheese is taking up, divide that by the total amount. That's how you figure out a percent composition. That's what composition means, what makes it up. Empirical formula is a little bit different. What we're doing is we're starting with our percents, or we're starting with grams. And then we move on into finding the formula. So let's look at number 20. All right. Number 20 tells us that we have 32.8% chromium and 67.2 chlorine. Sorry, that should be an R. My bad. Let me erase that. Now, if we have a percentage, we can turn it to grams. All right, and then what we're going to do, so our first step, get to moles. 67.2. We get to moles. The way we get to moles is we divide by our molar mass. So the molar mass of chromium is 52, and the molar mass of chlorine is 35.45. So this ends up being 0.631, and this one ends up being 1.90. So our second step, divide by lowest mole. So which one of these guys is lower? CR or CL? CR. So I'm going to divide both of these guys by 0.631, excuse me. So this becomes 1, and this one right here is 3.01, which, you know, that's cool. And then we have two options. We can either round, or we can multiply. Now, the only time you multiply is if, for whatever reason, you get a number that is outside of the rounding area, which is 0.8 to 0.2. So if you get a number that's 1.5 or 1.25 or 1.33, you can't round that number. So you have to multiply by 2, 3, or 4 in order to get that. All right, and on this part right here, basically the last step is plug it in. So this becomes CrCl3. That's the answer to this last problem right here. All right, so I'm going to come back in the next video. I'm going to show you what one looks like if you don't have, whenever you do have to multiply.